Hi, for iGen 330, our team made up of Caleb, Sadul, Shauna, and Vedant worked on a prosthetic alignment jig save and reset device. Prosthetic clinics such as Barber Prosthetics often have a very long wait time due to the limitations posed by their jigs. Currently, the prosthetic alignment jigs can only hold one prosthetic at a time and cannot record any alignments. Thus, the jig cannot be used for another prosthetic until the previous one has been completed, greatly lengthening the time it takes for a prosthetic to be made and limiting the clinic's order capacity as well as the patient's wait times. Therefore, we are seeking to develop a novel jig or device that will enable the critical alignment of multiple prosthetic sockets and components to replace the current manual system which can only align one prosthetic at a time.
Our primary customer is Barber Prosthetics Clinic. However, we are hoping that with the success of this project, we might be able to expand our customer base to other prosthetic clinics. Meeting with Barber, we defined the requirements our design had to satisfy. Our device had to be able to accurately measure critical prosthetic relationships and be able to recreate these relationships for multiple prosthetics at a later time. Barber also required that our device be cheaper than current industry alternatives and also that it should be easy for their technicians to use. Barber requested we avoid, or at the very least minimize the use of electronics, as they were concerned with the electronics failing, and as a result, halting their production process. We were also constrained by our iGen budget.
From the given problem statement and information from stakeholder consultation, we began generating ideas for possible solutions. We found we could simplify the problem and reduce costs by designing a device that would record the setup of Barber Prosthetics' current jigs instead of designing an entirely new jig. After exploring electrical and mechanical methods of recording the state of the jig, we settled on a mechanical design. Our final design, the Save Reset device, or SRD, uses modified spherical coordinates to record the jig's position. The device is built around a central laser pointer, which is positioned by adjusting the pan and tilt of the device. A technician uses these adjustments to position the laser pointer dot on the footplate of the jig before using the measuring tape located on the side of the SRD to record the distance. These measurements effectively give us two angles and a radius which defines the relative location of the top and bottom of the jig. Here we can see the SRD being secured into the top collet of the jig. The pan and tilt adjustments are then used to position the laser pointer before the measuring tape records the distance to the footplate.
From our discussions with Barber, it was clear that we needed a method to verify the functionality of our device that the technicians at Barber could use at any time. Thus, we developed the finite positioning device. The FPD has 4 configurations mimicking 4 prosthetics. These multiple configurations will allow the technician to test the full range of measurements possible with the SRD. The FPD is comprised of 3 head joints connected using 3 pipes. The use of 3 head joints ensures that the bottom pipe remains in a vertical position in all of the configurations, so as to allow the FPD to be attached to the bottom footplate of the jig. Both the top and bottom sections of the FPD were designed such that it can be attached to the jig in a similar fashion to actual prosthetics.
Our solution could speed up production by 2 weeks, eliminating a manufacturing bottleneck. This will allow at least one more prosthetic to be made per month, reducing the wait time for people who need a new prosthetic. On top of this, our solution is much cheaper than the industry alternative by about $5,000.
Looking forward, we will increase the durability and stability of our device. We also want to make it easier to take readings from our device and increase the accuracy of its measurements. Nonetheless, our device successfully meets the needs of our client. It allows for alignments to be reliably and accurately recorded and reset as needed. The technicians working at the clinic are excited to try our device and share it with colleagues working in the industry, and we are excited to be able to make a difference in people's lives and give back to the community.